So we're going to look at an example calculating arc length. Over here we still have that set up from the introductory video, right? The idea being that if we want to calculate the length of a curve, which is not something that we technically know how to do, we know how to calculate lengths of line segments. Well, if we split our curve up into little line segments that are approximately the same as the curve, we can calculate the length of each of those line segments. We add it up, we get a Riemann sum. We arrive at a formula that looks like this, right? And the only trouble with this formula is that sum under the square root, it often leaves you with difficult integrals. So we choose our functions carefully to make sure you can evaluate things. Let's see how it looks here. Here's f of x. We calculate f prime. F prime of x is going to be 3 over 2 x to the 1/2, right? So when I do 1 plus f prime of x squared, well, that's 1 plus 9 over 4 times x, right? Square the square root, we just get x. And this is not so bad as something to have under a square root because it's linear, right? We know how to do linear substitutions. Linear substitutions are simple. So our integral x should go from 0 to 4. We have the square root of 1 plus 9 over 4x. And we might as well set this up as a u substitution, right? So we'll let u equal to 1 plus 9 over 4x. That means that du is 9 over 4 times dx, which is the same thing as saying that dx is 4 over 9 du. And from here we can also see that u, when x is equal to 0, u is equal to 1. When x is equal to 4, when x is equal to 4, getting ahead of myself. When x is equal to 4, u is equal to 1 plus 9 over 4 times 4, which gives us 10. How convenient. Okay. So if we put everything in, put that 4 over 9 out front, just so you don't have to worry about it. Integral from 1 to 10, square root of u times du. Well, that's simple enough, right? So keeping in mind that square root of u is u to the 1/2, power rule says add 1 to the exponent, we get 3/2, divide by the new exponent, so dividing by 3/2 is multiplying by 2/3. 2/3 u to the 3 over 2, and we're evaluating from 1 to 10. Okay, well, not so lucky here in the sense that nothing really cancels out in these constants. 2 times 4 is 8, 9 times 3 is 27. And we put in our limits, we have 10 to the 3 over 2 minus 1. Leave it like that. I guess if you want 10 to the 3 over 2, you could write it as, I don't know, square root of 1,000 if that seems nicer to you, or leave it as 10 to the 3 over 2.